Okay, great. Well, thank you all very much for coming. Today, we're going over the architecture with Albert. We will have different broadleaf engineers throughout this week. And I will be kind of kicking off each day to make sure that we're all set up well, and then dropping. So please let me know in the meantime if there's anything else. We will continue to follow up with questions, and I will continue to be the main point of contact for that. But with that, I will hand it over to Albert, who will be taking us through our session today.
All right, thank you guys. Yeah, so as Brad mentioned today, I'm really gonna set up our and really go at a high level here and really start at the top and kind of give you an introduction of broadly from a high level architecture perspective. And throughout this week, as Brad mentioned, we're gonna have different engineers come in and kind of talk about and go into more details around specific parts of the system. I think we sent out a sample agenda of what we're going to cover on each of these days. But really, from today, we're going to really start at the very top, cover some high level concepts, and really introduce you to a lot of the terminology that you're going to hear throughout all these sessions, so that you get a kind of a baseline understanding of how things work within the framework, and kind of talk about some of the resources and other code snippets and demo starter applications that we have that can help you learn the different parts of the system and the different components that make up the full ecosystem of broadleaf microservices. So with that said, let's start off with kind of a really high-level introduction of what the agenda is for the rest of this week, and starting with today. And this is really sort of the agendas and some of the bullet points that we'll be covering throughout these particular sessions, starting again with today covering really the high-level architecture. I'm assuming that a majority of the folks on this call have been able to look at and review those prerequisite videos that go over at a high level how to get your local environment running. I'm going to kind of review that with some slides in the beginning here, just to make sure that we're all kind of starting off at the same spot, and just reviewing some concepts there in case you guys have any questions around that process. And feel free to, as we go along and you have additional questions, feel free to ask those, and I can deep dive into those particular topics as well. I'm also going to talk through kind of the general scope of all the services that we provide, talk about this idea of bounded context and what that means with our microservices, the different service types and the different components that make up the system. We're going to talk about the supporting services that are required to run the different parts of the system. And then we're going to finally end it off with really kind of doing a hands-on walkthrough and a demo of our baseline admin, and talk about those terminologies that we talked about and how that relates to what you're seeing in our back office admin, and what that necessarily means from an API or a consumer-facing storefront perspective as well. When we start getting into day 2, day 3, and day 4, we're going to start deep diving into each of particular microservices and the different extension paths that you might need to take when you are actually implementing it, your project yourself, right? So in particular, tomorrow, we have Marie that's going to walk you through our catalog microservices, walk you through the catalog browse microservices, and those are examples of what we call a resource tier and a compositional tier service, and walk you through kind of extension paths to those particular services, because we know that's a very typical extension path that most implementations will go through. And then we'll take you through sort of just a hands-on walkthrough of coding that extension and coding that extension and adding a debug point in your IDE and making sure you're available to you're going to be able to do that yourself when you're running this locally yourself. And then finally, day 3 and day 4, we're going to again focus down on particular workflows and commerce specific functionalities and the services that impact those, particularly the checkout services, which encompass our transactional type services, from our cart and cart operations to order and order operations, talking about our checkout workflows and integrations with payments. And then from a front end perspective, we're going to talk about the SDKs that we offer whenever you're building out your front end SDKs, your front end consumer facing experience, and what you can do to extend and augment the back office admin to support your particular flows as well. And then finally, we're going to wrap up with talking about some key microservices such as our auth, our search, and our pricing and offer microservices. And we're going to kind of cover some key topics around that. So hopefully that made sense. And kind of over these 4 days, we're going to deep dive into those particular topics. And then again, as you have questions as we go through this, we can definitely take those questions and either answer them now or take them offline for follow-up as well. So let's go ahead and move to architecture concepts. And really, I'm going to start really at the very top here and kind of really talk about if those of you who aren't familiar with Broadleaf and haven't been in previous sessions or other kind of calls that explain how to use Broadleaf, what Broadleaf is, this is kind of a really 50,000 foot high level overview of what Broadleaf actually provides. And the solution overall provides a lot of value in a lot of different areas. And to really help illustrate the scope of all what Broadleaf provides, it really does kind of help to think about the different audiences that benefit from using and experiences different parts of the solution, right? So I'm going to start with one of our main target audiences, and really a lot of the audience that I think are on the call today are really those core back-end commerce developers, because at its core, Broadleaf is a framework, and it's kind of very well suited for a variety of different, complex commerce scenarios. And we do that by providing a set of enterprise level commerce APIs, right? And these you can think of them as headless APIs that span an ecosystem of over 30 different microservices. By itself, it does provide a lot of rich functionality, including a lot of out-of-box concepts to support some key complexities, to support a variety of different business models, and I'll touch on that in the next slide. But these APIs do have a lot of powerful features to facilitate a variety of different commerce use cases from, and supports a lot of different verticals and industries, whether that's retail B2C, contract pricing in a B2B scenario, or sort of a marketplace vendor catalog management scenario. We do have those, key features and functions kind of spanned across these sets of APIs, and they can be leveraged in a variety of different ways, right? So now I do want to point out that these core APIs are built on top of a microservices backbone, and it does allow you to plug in your own services to work within the Broadleaf ecosystem. But you also do have the flexibility to plug these into an existing ecosystem as well. I'll touch on the technology, and we're going to go into more depth around the technology that powers all of this on the next slide, or the next 2 slides. But as I mentioned before, it is typical for our clients to extend our APIs to basically suit their particular business needs. And with those updates, we provide a lot of tooling for that evolution to become natural and easy. So again, I'll go into more detail around the mechanics of extension in the next couple of slides, but In the meantime, just think about, as an example, as a full stack backend developer, you'll naturally be either, using our out of box commerce APIs, or you're extending the ones that we have out of box, adding your net new endpoints if you need to. And for those individuals, we're providing an extensible open API framework that allows you not only to experience and test the core out of box APIs, but also gives you the ability to grow those specifications as well. So you'll notice, and I'll go into the details, you guys should have access to all those starter accelerator projects that we gave you. One of those is that open API deployable. So you basically get access to all those schemas that represent our out-of-box APIs. You can extend those. You can add your own as you kind of develop and implement your own platform on top of Broadleaf. And then, with commerce in general, you'll naturally have some customer-facing applications. I think I recall that you guys already have an Angular application. What we have to support sort of those front-end applications, we provide a Next.js customer storefront accelerator. And this is really a project that's meant to showcase the features and capabilities of the framework using, best practice UI, UX commerce flows. A lot of our clients use that accelerator to really help bootstrap their project implementation. They either use that and start building on top of it, or they'll use that as a reference point to figure to see how they can call and utilize our JavaScript SDKs, and what are the best patterns to use those to build out, for example, a PDP or a PLP page. Again, they'll either use that up front or they'll use that as an accelerator. In addition to that, this accelerator is built using our JavaScript SDK libraries, which is included in a variety of different clients. So you can that really helps accelerate the development of other channels that might not be using our storefront. Now, if we focus on business users such as merchandisers, vendors, and customer service agents, for those particular individuals, we do provide a powerful back office administration console, and I'm going to go into a lot more detail about that at the end of our session as well, and I'll talk about what we provide there as an admin back office framework. And this is kind of unique because it not only allows you to manage, function as a unifying admin to manage data and workflows across all of our microservices, but it also provides you, kind of how have I alluded to before, a metadata framework and component libraries that allows you to build management capabilities for your own services and extensions as well. And then finally, at the bottom right here, now that you kind of have your tailored commerce solution, you might be wondering, well, so how do I actually put that in production? Again, flexibility was a kind of key tenet that we wanted to provide here. So what we provide here is reference Helm charts and reference infrastructure that allows you to deploy the microservices in a lot of different ways, right? So again, I think we spent some time here already trying to get this deployed to your OpenShift environment. So you guys or some of you might be already familiar with what we provide here from a DevOps and deployment perspective. All right, so let's get into, and this is kind of going to be a review of the high-level topology and the reference architecture that we give you. And this is really, it's a corollary to the projects that we're actually giving you as accelerators. So you may have seen this already in kind of those storefront accelerators that we've given you, and that GitHub repo that you have access to. And it's good to kind of think about these in the different tiers and the flows of how, for example, a particular request is flowing through the system, because that will kind of give you a mental map of the different tiers of the application, and I'm going to go into each of these different tiers and kind of explain in more detail. So just kind of refer back to this diagram as I walk through the different sections of this presentation, and kind of as we get into more sessions later down the week, we're going to deep dive into particular services and talk about more specifics around how that service fits into this overall ecosystem. So again, at a very high level, if you think about the requests flowing from custom applications, whether that's the back office admin console, whether that's a request that you're testing out from the Open API, Swagger client that you deploy, or whether that's your Angular app or that custom Next.js storefront, those requests will flow through one of the first layers that you're going to learn about is our gateway layer. And this is our gateway layer is it's not required, and I'll go into more detail. I have a slide specifically on this, but just know that these are really lightweight, basically proxy applications that route the requests down to various services on the back end. So whether it's a Node.js server that's servicing the React back office admin, or the Open API framework, or the Next.js storefront. Go ahead.
Albert, how are you? This is Shoaib Farouk. I'm so sorry for interrupting you. I would like to ask something here related to the which microservice assuming the role of API gateway. I mean here, the communication between the front end in terms of SPA, single page application, to the microservice at the back end. Is there a direct communication between each API from each microservice, or there is a specific API gateway, okay, getting the request from the front end, then dispatching this request according to the business logic, okay, to specific microservice? Do you understand my question?
Yes, absolutely, and that is exactly that's a great question, and that's I have a slide on this in two seconds, but just to high level answer your question, it is the second thing that you mentioned, where the API, all this front end applications, at least in this reference architecture that we provide to you, all requests, whether it's from a storefront SPA or the back office SPA, are going to flow through an API gateway, and the API gateway has routes on them, which will then delegate to the backing microservices. So the SPAs in our reference architecture that we give you are not communicating directly to each microservice directly. They're all going through an API gateway, and I'll talk about why we do this in just a second, but hopefully that answers your question around.
No, yeah, this is very good for the time being. I'll be waiting for the flow of your presentation in order not to interrupt your presentation flow. So please continue.
Absolutely, and these are great questions. So thank you for, and feel free to kind of interrupt as well. So if there's nothing clear I'm saying, and yes, and just that's a really good point, because this gateway layer does function as a router and proxy for all requests from the custom applications that you see here, whether that's the storefront or the Open API or the back office admin, right? And those requests will flow through those either gateway, and will basically hit a backing microservices depending on what route the front end is trying to hit. I'm going to talk about in more detail this particular layer here, which is the core, really the core commerce microservices. And I'll talk about, and we're going to deep dive into these sections, not only today, but especially in the next few days as well. We're going to focus on particular microservices that are relevant to your needs. But we're actually going to categorize these into what we call different service types. And that's going to help really solidify in your mind the different types of microservices that we offer with our system, and hopefully give you a little bit better understanding how we like to categorize things from a backing microservices standpoint as well. And then finally, we're going to talk about, we're going to touch on sort of the supporting architecture and the supporting services that are needed to basically underpin and run the various microservices, whether that's a messaging broker or a database, and then finally a search implementation or a search engine as well. So there's a handful of supporting microservices or supporting services that are also needed to support the running of all of these services in general. So let's go ahead and focus on the next one of these supporting services, and that would be the messaging layer. And obviously with microservices, there's actually going to be two components of how microservices talk to each other. Let me go ahead and get tools in there really quickly. And from a messaging perspective, you get, so from a microservices perspective, you could think of requests being serviced in two ways: a synchronous perspective and an asynchronous perspective, right? And when we're talking about messaging, this is particularly focusing on the
شوقي استاذنك المايك مفتوح يا شوقي.
the flows that are servicing things from an asynchronous perspective. So when a service, for example, service A here needs to asynchronously communicate a message to service B and C, that's where kind of that messaging layer comes into play. And I'm going to talk about in more detail here. I know this is at a high level, but just there are certain flows within the system that rely on this asynchronous messaging. So for example, things that happen in the admin, that you change an entity or you change a particular, you make a change in the admin that needs to communicate that change to multiple microservices. That happens not at a direct synchronous layer, and that happens more at an asynchronous messaging layer. And one of the typically kind of when you're looking to integrate these services together, you're looking to utilize this concept of a messaging broker, right? So for example, if you want service A to communicate to services B and C, you know, typically as an implementer, you would implement maybe a message producer class in service A and then separate consumer classes in service B and C to handle that message, right? Now, typically, you would have to create implementation specific to the broker that you're choosing to use, right? What we've done and chosen as a framework is to implement that in an abstract way, utilizing the framework of Spring Cloud Stream. And Spring Cloud Stream allows you to basically abstract the details of particular brokers, and instead of creating consumers and producers that have specific implementations that are tied to specific brokers, what Spring Cloud Stream allows you to do is provide you APIs that can abstract those details away, and you can basically implement the Spring Cloud Stream API, which then delegates to binders that they have. There's libraries that you can plug in from a Spring perspective, and they will implement the specific connector code that that relates to these different binders. So for example, they have binders that are specific to Kafka, binders that are specific to cloud native solutions like Google PubSub or Amazon Kinesis. They will have, and they have, there's a whole ecosystem that are, excuse me, that are, that allow you to plug in these different binders that allow you as a developer not have to worry about the implementations that are specific to you, but really create those producer and consumer classes in an abstract way, right? And that and broadly does that really for two reasons.
Can I interrupt here? Excuse me, Albert. Okay. In such situation, after importing such classes, when we are trying to customize or trying to implement something new for our business, I have to make this implementation inside the same microservice, or I can import such a class outside this specific vanilla version of your microservice and then implement another one, okay, or another microservice built by our team.
Yeah, so I think there's kind of two aspects to that. There's if you're extending an existing microservice, so for example, our catalog microservices where you're maybe extending our product and you want to add a net new, let's say, consumer
Attribute, new attributes.
new attribute.
I need to add the new attributes in an existing API from Broadleaf. Okay, it's okay. Continue.
Yeah, with that example, yes, you are going to be extending our existing catalog microservice, and that's actually, we're going to go into a lot of detail, and we're going to show you how to do that in our next session. That's exactly our the details of our next session. But at just a high level, for that example, if you want to add a new attribute to product, you would extend product in our catalog microservice. If you want to extend a binder or a producer, a message producer, you can do that in our catalog microservice. And all you're going to be using kind of the same framework, and we have patterns that kind of showcase how to do that in our microservice.
It's okay. This is very good. I would like to add a hand here. In our mind here, when we are trying to design the architecture of Broadleaf inside Vodafone Egypt, we might think about to standardize to standardize the images from Broadleaf and any customization to be built outside your images in order to keep your image without any touch from our side. يعني just keep this in your mind if this is applicable or suitable for the framework or not. Please continue. I don't want to interrupt more. However, this is what we are thinking here in Vodafone Egypt, to build another cluster or another namespace for Vodafone customization and keep Broadleaf as a standard version as long as we don't need an important involvement from our side inside your code.
Yeah, so there's actually kind of two things to that. I'll get into that. I'm not sure if there's not really a standard image, so I want to make sure that that is a clear point, that you're still going to be creating your own images that might not have any customizations to them, but they're going to be images that are produced by you. So I want to just make sure that you're clear with that, because we don't produce images. We produce jars, and I'll go into a lot more detail on what we're actually giving you and how you customize that. But you can basically get the jars and produce your own image and not make any customizations to it, which I'm thinking is what you're saying, is you might have services that you're not going to touch, but you might actually have other services that you do touch, right? So,
okay, the reason behind the interruption, that's to be sure that this point will be covered either today or even in later sessions. That's it.
Sure. I'll make sure to touch on that today as well, on what we're actually providing you as and I'll walk through that kind of reference storefront and those accelerator code bases, and kind of touch on that and how we envision you using that in your system. So again, hopefully this made sense from a messaging perspective. We utilize Spring Cloud Stream as that abstraction layer. I think are you guys using Kafka as a binder, or do you have an internal messaging system that you would rather use? I'm not sure if
For the time being, we are not using something like Kafka. We are using, in some cases, normal GMS as a messenger queuing, but in rare cases. However, in our big data solutions inside Vodafone Egypt, we are using Kafka heavily because of the number of messages and so on. We can say that we don't have such experience in Kafka or dealing with Kafka for the time being. However, we will learn together. In this point, please try to cover the questions that I will ask you now, which is, I don't want to to use this discussion between myself and Khaled and Attar. I don't want to use Zookeeper, for example. Is there any alternative? This is keep it in your mind just to cover this point in later sessions as well. But the answer for your question, no, we didn't use Kafka before, but we have some information about it.
Okay, so one point to talk about there is we understand that you probably haven't used Kafka before, but there is a decision that you guys are going to have to make in terms of a messaging layer. So whether it's Kafka or if it's RabbitMQ or whatever, I think our recommendation is Kafka because we have a lot of experience on that, and our reference architecture utilizes Kafka. If you don't have, I don't think you're going to have the option to use a cloud native messaging architecture. So I think Kafka is probably going to be our recommendation for you guys to deploy that.
The answer is confirmed. Yes, we are going to use Kafka, especially this is the standard one you are using in your environment in order to have a proper support from your side in case of any issue related to this kind of architecture. The answer, yes, we are going to use Kafka as a recommendation from Broadleaf, and this is what we will go for in our implementation.
Okay.
And keep the question related to Zookeeper in your mind, please, in order to be covered in later sessions, even today or tomorrow or whatever.
Okay, so I'll talk about the I'll touch when I go into sort of the infrastructure type pieces. Why Zookeeper is needed. Zookeeper, for the most part, is needed for two things: Kafka and.
You don't have to answer to now, Albert. No problem at all. We will wait with you. No problem at all. However, just to keep it in in our mind,
Understand.
in order to see alternatives for Zookeeper. يعني the point here to to minimize the single point of failures as much as we can in order to have a clear, fail-safe environment. This is our objective.
Understand. All right, so let's keep going, and I'm going to kind of talk through the next kind of layer that you saw in our diagram here, which is, and this goes back to Shaki's original question, is that API gateway layer. So in our reference architecture, you saw two of them on that diagram, and while these are not necessarily required, you can have a deployment where you're talking directly to the backing services, but we do highly recommend the use of an API gateway layer, and it is part of our reference architecture because of there's a lot of pros that we see with using this idea of an API gateway layer, right? So again, our reference architecture and our sample storefronts gateways, one of them is an API gateway that services requests from a back office and internal consumption perspective. So you're going to get requests from the back office admin or the open API, and it's going to route it to the backing microservices. And then secondly, the second one was for the customer-facing storefront. So all customer-facing requests from that, either the React storefront or from, let's say you have a mobile app or some other application that is customer-facing, all those can route through what we call the commerce gateway. And what that allows you to do is there's a lot of advantages of doing that. One is you can, easily support something like cores where all your single page applications all have to go through a single endpoint, and you don't necessarily have to enable cores from a front end perspective. It also supports the idea of you may have heard the term BFF, or a backend for front end pattern, which is a very typical pattern in a microservices architecture, where you might want to facilitate the routing in this kind of proxy layer that routes the requests, and you can have multiple gateways that are segmented from a security and firewall perspective that might only allow you to hit APIs that are accessible from a back office perspective or from a front end perspective, but you can still leverage the same backing microservices to service those requests, right? So that API gateway is another level to allow you to support that type of architecture. What we do,
This is part from the implementation for the time being from Broadleaf, right? As I see from your slide, this is based on Spring Cloud Gateway, right?
that is correct. So we provide you a proxy. It's a very lightweight service, microservice that you can stand up yourself. And we're giving you one that is built on top of Spring Cloud Gateway. And Spring Cloud Gateway, if you guys are not familiar with it or have not used that before, it's a very lightweight framework that, and it basically just, it has hook points in it that allow you to add pre-request filters and post filters that allow you to basically translate the request or do additional kind of rich things that you can do to the request. But really at the end of the day, the code that we're giving you from that gateway layer is very simple. There's actually no code in there. And all it is configuration. So this is a screenshot of the configuration.
Albert, if I may ask,
Yes.
you are not using Zool as a gateway. This is another
That is correct.
Spring gateway. If I may ask, why did he use this not Zool if this has more benefit from it?
Adding to this question, why you are not using the Kubernetes service orchestration?
So we are. So we're using Kubernetes. Well, for one, Zool, I think from a maintenance and lifecycle perspective, from what I've read, and I may be wrong about this, I think there's an end of life with Zool, and that I think Spring in particular is moving or transitioning that project into something else. I don't know the details.
Yes, this is right. This is right, Albert. Even Netflix trying to switch to something else. Most of cloud-based architecture now built on the orchestration done by Kubernetes itself.
That's right, and that's what we actually use as well. So we rely on. So there is no real service discovery, or we don't really have a service discovery layer in our architecture. Not saying you can't use that, but with our reference, we don't use that because we do rely on Kubernetes, basic networking capabilities. So we'll leverage the DNS capabilities of Kubernetes to hook up, at least from a DNS perspective, where are the different services located from a domain name perspective. So we take those domains and we configure that in routes, and that's basically all that Spring Cloud Gateway that's very simple as to what Spring Cloud Gateway provides. And really what they provide is just a routing mechanism that allows you to look at the incoming requests. It looks at what is the backend gateway that we want to try to hit in that request. Do I need to rewrite that URL? Are there additional filters that I want to apply before routing to that backend gateway? So that's kind of one of the things that we like about Spring, is because a lot of our backend microservices are built on Java and Spring, and the extension patterns are very natural to use because we also use that in our framework as well, right? So this idea of adding additional filters, and one of the out-of-box things that they provide you are things like circuit breaking or rate limiting. If you want to add that to your repertoire of things that you want to supply at that gateway layer, you can basically leverage their out-of-box filters. And we actually have, I misspoke when I said there's no code in these gateway layers. We actually give you an example of how to leverage one of those. We actually provide you an example of a layer that we've built into here that allows you to basically look at incoming requests, and if it's an anonymous request or a guest customer, we basically look at that and then append like an anonymous token to that request before forwarding it over to the backend microservices. So we actually use some of the concepts of Spring Cloud Gateway to support various flows that we think are very natural to support in this Spring Cloud Gateway layer. So again, we don't not use the Kubernetes or the Docker, domain name or the DNS capabilities that are inherent to that. But really what the API gateway layer provides you is that routing and proxy mechanisms to look at incoming requests from a client run through a couple filters or extensions that you might want to do to either manipulate or enhance that request before forwarding it out to a particular microservice. So
Understood. This is very good. عمرو انت اعتقد this is very clear for us, right?
Yes, clear.
Okay, I would like to ask here, after delivering the request to specific microservice, after passing by the API gateway, in our case, Spring Cloud Gateway. Okay, as I understood from your architecture, there is no, or there is minimal internal communication between microservices together. I mean, communication APIs, communication between pods underneath, but using Kafka instead for having a producer and consuming later on. This is my understanding. So there is no massive communication between pods between each other. Okay. However, for example, you are sending a specific request to specific microservice. This microservice will do some logic and send to Kafka as a producer, and the other one listening to this message and consume this message and reply back to the request to the requester in the SBE, whatever admin or storefront. Is this right?
Almost. That's there is communications when you get down into the backing layer, synchronous communications when you get to the back office layer in certain scenarios. And I'm going to talk. And you're jumping ahead 2 slides, and I'll get to that in just a second.
No. You don't have to jump. But I mean here you are using for sure. There's some sort of direct communication between pods or microservices together, but minimal. But minimal, not massive, not massive one.
Exactly, and I'll tell you exactly which scenarios there are direct communications, and we basically have a different type of service that does that, and that's a really great insight that you had. And I'm going to talk about that in just the next 2 slides. So
no problem. Continue in your flow. No problem at all. I'm fine. Okay.
Okay, Albert, I need to ask: is this gateway implemented in current OpenShift and testing demo and local demo? I didn't saw it.
It should be. Yes, it's called Open API. It's called Commerce Gateway and Admin Gateway. So let me actually open up something for you as well. Apologize. Let me look at something here.
I mean API Gateway, Albert.
The API Gateway. It is installed there. Oops. I'm not, sorry. 1 second.
I believe there is a pod or there is a microservice called Admin Gateway and Open API Gateway. I believe I saw it before, if I remember well.
Yeah. Let me actually. I'm going to show you a example cluster. Now I'll jump back and forth to this as well, as so that we can kind of look at this together. Maybe it'll give you an idea. This is not your cluster. This is our kind of test sandbox cluster that we have set up. And let me just, hopefully it's in here. There is, if you look at the topology of it, you're going to see one called, in the web stack, there's one called Commerce Gateway, and then there's one called Admin Gateway. These are the 2 API gateways that, if we look back at our diagram here, just to, I think this is a really good way to kind of refresh and make things clear in your mind here. These 2 API gateways that are related to those deployments in your OpenShift cluster, right? So this gateway, API gateway, is responsible for handling requests from our back office admin console, as well as the Open API. And then there's a Commerce Gateway that's handling requests from the storefront application.
Okay, it's a small question here, Albert. Why storefront and admin UI is connected in this diagram to gateways, then gateway is connected to front ends?
Right. So why are they separate? Is that what you're asking?
No, not separate. Why? Like priority. Why the front end not first, then gateway? Okay, as I understand, front end talks to gateway, then gateway talks to commerce microservices. Is that right?
No, so the maybe this is a misleading diagram, but this is basically this represents a deployment in your OpenShift cluster. So for example, admin web is related to this guy right here, and commerce web. So this is just, if you actually go into what's running inside this pod, it's just a Node.js server that's servicing the initial client SPA, right? So it's going to produce the initial requests for that client-side application. And then at the end of the day, in the browser, those requests are going to make its way through the gateway. So all the SDKs and everything that is coded within that front-end application is configured to make requests to the Commerce Gateway. And basically, it's going to go in here, and then the Commerce Gateway is going to route to the particular backing microservice and services that way. So these are actually just the Node.js servers that.
Okay, I understood. That's why I was asking. Thank you.
Great question.
Again, sorry, I didn't get this point. You need to mention that this layer just to forward the request to the core commerce microservice.
That's right. So the API gateway, all it's really doing is, and you can see here, this is just a snippet of really the core important pieces of that project. And let me actually pull up another. This is a good actually thing to illustrate as well. So if you guys have access to, or if you recall, the starter projects that we give you, one of the projects is called Microservices Gateways. And this is basically the code that is deployed here and here, right? So the code that we give you, there's an admin and commerce project in here, and it is very simple. There's actually not very much code in here, and it's all it is this Spring configuration that tells you how to route the request to the backing microservice. So again, you can add your new filters in here. You can add new classes that implement certain filters that Spring Cloud Gateways provides to you if you want to have more advanced functionality. But at the end of the day, this is the most important part, is basically a request that comes in. How am I going to route it to a backing microservice, right? And it does that by looking at the paths that are coming in and then figuring out, do I need to rewrite that path to something else so that I can forward it along to the backing microservice. Hopefully that makes sense to you.
Yeah, okay, but I have another question. What if I need to communicate with the core commerce? Should I communicate it directly using the API or using the Kafka?
Yeah, so great question. So if you want to, like, it depends on who you are. Are you another service, or are you a front-end application? Like, what is the use case that you're trying to solve there? I think that question, hold that question really quick, because I'm going to go into details of the different service types, and I think that's going to answer your next question here. So let me get to that in just a second. One of the other layers before we actually get into that is, I want to just make sure that you're aware of this, is we have concepts, persistence concepts in Broadleaf. And there's several persistence concepts that are very specific to Broadleaf, and they're mostly transparent to you, but it's important to be aware of because it plays a lot in the functionality and a lot of the enterprise features that you're going to see throughout Broadleaf. They're basically the bread and butter of how those functions. And there are really two concepts that you should be aware of, and one of them is called data tracking. And data tracking is, you can think of it as like a very advanced versioning mechanism, because it not only keeps track of changes of what for example, you make a change to a product, and that change is version 2 of the product. So it not only keeps track of basically the version, of one version to the next, but also, how those versions are applicable and different based on who needs to see that particular version in a particular context. So, for example, who's requesting to view version 2 of that product? In what context are you trying to view it? Are you trying to do that in a preview mode before you actually get into production? Are you actually in production with that version? Is there a particular scenario where that version of that product is only applicable to that customer or to that catalog that is viewing that product? So there's a lot of interesting things you can do for a single, quote unquote, version of a product. We keep track of in terms of this idea of a data tracking capability. So again, all of this is transparent to you as a developer, but you should be aware of it, especially if you're adding net new entities, or if you want to create things that are also have tracking capabilities. You have the ability to leverage these same libraries and components to add those to net new entities that you create yourself. And we basically have annotations that you can add to your entities, and patterns that you would just leverage and say, I want this to go also be tracked the same way that products are tracked. And then basically these concepts are not limited in scope to just the broadleaf domain. And if you want to use that for your own net new entities and controllers, you also have the ability to do that by just adding the dependencies to our common libraries to your code as well. So just note that if you're adding net new concepts and entities that are outside of Broadleaf's kind of out-of-box entities, and you also want to leverage this idea of data tracking, you have the ability to do that. One of the other concepts that I want to make sure that you're aware of is that we also leverage Spring Data for persistence as well. So we utilize Spring Data basically to reduce boiler code, typically required for just basic database interactions. So you basically code to the Spring Data API, and it gives you a lot of things out of the box where you can get all these inherent database persistence methods and API methods at that interface level without having to code all this other boilerplate stuff that you necessarily have to do in a typical implementation. So we use Spring Data as well.
Sorry, Albert.
Yes.
What if I need to get the product from other, maybe other application or other service not existing in the Broadleaf, maybe external applications?
So you want to make a call out to another service.
Not existing in the Broadleaf, yeah, maybe in the other system, other applications that having the product catalogs for us. So we need to get the product.
Yeah, so we have a concept called an external provider that you can leverage, and that also, I think all these questions are pointing towards understanding this idea of an orchestration layer. So actually, I want to go into that one really quick because I think that's going to solidify some points in everybody's head here. I want to talk about, let's see, hold on. Let's see. One second. I'm sorry. I apologize. I'm going to keep going here, but this is important. Okay, so there is, if I look at the different, if we kind of drill down, if you remember that one diagram at the very beginning where we saw those list of core commerce services, there is, you can basically break those services down into different tiers. And actually, I'm going to go back really quick because there's a better slide. Is this slide that talk about how we like to think about those core commerce services. Those core, the full suite of broadleaf microservices does span an ecosystem of over 30 different microservices. And obviously this kind of diagram here doesn't show all of them, but it does give you kind of a good general idea of how we like to categorize all those 30 services into what we call functional tiers. And the key takeaway here is that, even though you can deploy these independently, they do kind of tie together with enhanced functionality if you deploy these different tiers, especially these foundational ones. They work better together if you kind of deploy them as a full ecosystem with enhanced functionality that offer kind of additional rich enterprise specific functionality when you kind of start including all of them into the ecosystem. One of them in particular, which I think is the crux of a lot of these questions that we're hearing about, is this idea of compositional services. So we actually have a list of compositional services. There are actually 3 of them in our portfolio, which we call orchestration type services that do have explicit dependencies to additional services in the ecosystem. And this is where those synchronous communications from an API to API perspective make sense. So, for example, we have one called Catalog Browse that has direct communication to our backing catalog microservice. We have that has a dependency to our search. And when I say dependency, it's not a jar dependency, but it knows how to communicate to those services directly from a synchronous REST perspective, right? And not necessarily from an asynchronous perspective. So the reason for that is to service, and I'll come back to this slide in more detail, but if I go into this idea about a composite service where it basically represents services that need to aggregate information or process information from other services. And an example of that is Catalog Browse. So Catalog Browse houses APIs that facilitate, for example, a product detail page. In order to produce a product detail page, you need to call out to a catalog service to get the details of maybe the product. You might also need to call out to a pricing service to fetch the details of that product for that particular context. You might also need to, call out to the search service to render the product listing pages. There are multiple services that you might need to do in a synchronous perspective to service APIs that make sense from a consumer-facing perspective. So in a lot of cases, and actually most of our cases, all of our storefront APIs are actually going directly to one of these orchestration level services because it has APIs that communicate to other services to produce the things it needs to surface a product detail page, right? So you're not necessarily going directly to the catalog service to get the product and then going to the product detail page or the pricing service to price it. You can go directly to the catalog browse service that aggregates a single API call to different services. Now, I think there was also an additional question around, what if I don't want to use Broadleaf's pricing service, or what if I don't want to use Broadleaf's, for example, inventory service? That is where the extension patterns we would recommend you would use to augment these orchestration services and plug in the RESTful connector to call out to those external services with what we call an external provider. So we have a pattern in place where you can basically plug in your external provider to these basically hook points where you say, okay, I'm going to call out to Broadleaf's pricing service, or I'm going to call out to Broadleaf's or your own inventory service to augment and support the API that is necessary to support the CardOps APIs that service things to the front end. Does that make sense? So hopefully that ties a little bit of the questions that I've been getting around how do I call out to an external service, or where do I do that? Or are there communications that are synchronous versus asynchronous? The three services in the ecosystem that you should be aware of, and I think are very relevant to client applications, are the ones that are what we call the orchestration layer services, or we also hear the term experience layer services. These are the services that have specific APIs that help build out the experience from a customer service perspective, or a consumer level perspective, and not necessarily, I don't need to go to the granular level and hit the CRUD APIs of each individual microservice and kind of tie those two together downstream. Does that make sense?
Yeah, yes, but sorry for this question, but if I need to get for the pricing from different, is I need to developing code, or just the configuration to get the pricing from external system?
You would have to build a code, but we have basically the interfaces and the patterns in place where you can follow that same pattern, and you would, as long as it has a exposable API that we could call, you would plug that into what we call an external provider into this service. And that's what we're going into in the next session, is details of how you can basically extend our orchestration services to make calls out to your own services if you need to, right? So that's what you would do, is basically plug in your implementation, because obviously we need to understand the payloads that are coming out of that other system, and then mapping it into basically our domain objects, or our DTOs that are being passed back to the front end, right? So that's not necessarily a configuration. That's we need to understand what is the other API passing in, and how do we marry that with the DTOs that are being passed back to the front end from this API. Does that make sense?
Yeah. Okay. I think it maybe another question, a lot of question, but I think it is early to ask it now, like how to extend it, your classes and so on. I think maybe I see.
Yeah. That's the whole sessions that we're gonna have throughout these are gonna focus on basically building out those extensions and building out how to work with specific services. So I just want to make sure that this particular session, you get a very, very high level view of all the components of the system. And then throughout the days, you're going to really focus on each of these particular services and how to use them and how to extend them. So these are the right questions you should be asking. But at least from this session's perspective, just try to get a brief view of the whole ecosystem as a whole, and make sure that you're aware of all the components of the system. So really, really good questions. Let's go back and kind of talk about this particular question, because our topic here is this idea of flex packages. You probably have heard of this, and you may have kind of saw this if you watched those introductory videos, and you might be asking, like, what is this again? And what is the purpose of this idea of flex package composition? So I want to just reiterate and kind of go over that topic again. One of the unique features and benefits of how we built Broadleaf is the idea of flexible composition. So again, recall that the Broadleaf ecosystem does have over 30 different services, and in some cases, an organization might not have the developed resources to manage a footprint of 30 different individual services, right? So that might represent a lot of DevOps overhead, a lot of maintenance overhead for certain organizations. one of the main reasons we developed that, and it's kind of one of the main reasons we've developed this idea of flex package compositioning, where we wanted you to be able to start, you know, in a simple way, but have the power to scale when you're ready to do so. And that's where kind of flex package compositioning allows you to bundle a logical set of services together. So for example, if I wanted to bundle the catalog microservice together, the pricing microservice, the offer microservices together into a logical deployment unit, I can do that using this idea of a flex package. However, it also allows you, if you're following the patterns that we set out for you, allows you to split out pricing into its own deployment in the future. Maybe, for example, let's say you get later down the road, you have a lot more requests for whatever reason, you get a lot more requests into pricing, and you feel the need that pricing might be better if you split that out and scale that independently outside the deployment of the rest of these services. If you follow our patterns and you follow the patterns of our flex package compositioning, and you do not mix this idea of bounded contexts, then you should have the ability to split this out and deploy that separately without that much work, right? So really, in essence, the framework not only allows you to flexibly compose each of these services together into a single deployable unit, it also allows you to flexibly decompose it as well when you're ready to do so. And we actually kind of showcase you how to do that. And you're probably wondering, like, why is this microservices demo, if I go back to this repo, you're asking, like, why is that microservices demo structured the way it is? Like, you have all these services kind of laid out here, and they're all kind of bundled into this one project. And the reason for that, again, it's to showcase this idea of flex package compositioning. So within that one project, it allows you to deploy under that single code base, to deploy it like this, where I want all the services deployed independently, right? So you would have 30 different services deployed independently, or I can have it deployed where some of them are actually bundled into what we call a browse flex package versus the transactional cart specific services together in what we call a cart flex package. All the long running back office tasks like scheduled jobs and imports are in what we call a processing flex package, and there's another one that does all the supporting stuff in a different one. We actually recommend for most enterprise clients, this is a really good starting point for most enterprise deployments, and because it does give you the benefits of segregating out the long-running back office tasks from the APIs that might be servicing customer-facing requests. So again, this is what we would necessarily recommend as a starting point for most enterprises. And then we also, this looks familiar to you, right? You're bundling all the services together in a single deployment. That looks like a monolith. But why would you do that if you're going down a microservices route? The reason you might want to do that is because it might be useful in a local development setup. I don't want to have my local development spin up 30 different individual Docker images, because that's going to take a lot of toll on your resources and systems to spin all of that in order to work with the entire ecosystem. What this allows you to do is actually create a deployment that includes all of the services into a single deployment, and I could just run I could either produce a single image here, or I could just run a single Spring Boot executable that has all these services combined, and I basically get all the systems. And then maybe in our QA or our production environment, I deploy it as this composition as well. So there's a lot of use cases of why we've built it this way, is because there's a lot of, it not only supports just a local environment perspective, a local development workflow, but also, from a scaling perspective, I want to deploy it in a different composition because that takes advantage of scaling things in the future, right? So again, don't think of this as I have to pick one and this is what I am stuck with. Think about it as what's going to make the most sense for me from a local development perspective, and what's going to make the most sense for me a deployment perspective, and what is going to surface my needs from a scaling perspective, because all of this is really a configuration change between this one and this one, and like all three of these. So make sure that you just keep that in mind. If you have more questions around that, I'm happy to kind of forward you some documentation or get into more detail about that, but just know that that exists, and that's kind of the reasoning behind why this particular project is structured the way it is to help support this idea of working in both the local environment setup as well as being able to deploy in different kind of microservice configurations.
The question here, can I use, for example, balanced composition, but I need to use, for example, the searching services as a separate service. Is
Yeah.
that possible? Or?
Yeah, absolutely.
So,
Great question. So you can. So do you mean that in a local setup, or like can you deploy
on production?
Yeah, absolutely. So you can. So basically, we give you, and that's a great point. I should have covered. We give you these three compositions as a starting point, but you have the ability to create your own compositions the way you want to. And we actually have a good example of this, and I'm going to go into more detail around what this is. But if you go into our what we call our developer portal here, there's some tutorials here that you should be aware of, and one of them is actually talking exactly about what you just talked about. So this is what we call a flex package mobility guide that talks about, if I'm starting with the browse flex package and I want to pull out pricing, what are the things that I necessarily have to do to pull out pricing from that, and I want to deploy that. So this basically talks about the steps that you would need to take. So I need to pull out the pricing jar from my POM, move it out into a separate deployable, make sure that our builds produce the pricing build differently, and then you modify the route to make sure it's going directly to the pricing instead of going to the one that's producing the browse flex package. So you absolutely have the ability to do that, and it really depends on what you're trying to do from your composition standpoint. When that makes sense for your kind of production deployment.
But in the development, it will be still in the one place. I mean, for the pricing is still, if I use the balanced composition or local setup or granular composition, is still in the Git, is still in one place. I just need only to configure the URL.
Oh, I see what you're saying. So you're saying, is there are these from a repo code standpoint, are they all in a single project or separate project? Is that what you're asking?
Yeah, I don't need here to exclude, or maybe
yeah, so that's a great question, and we've had clients do both. So we've had clients stick with this idea of a single repo and change their Jenkins pipeline, or however you guys are comfortable building your Jenkins pipeline to produce, and we kind of do this internally. We have a kind of a advanced Jenkins pipeline workflow that looks at the single project, and it produces all of these compositions under a single build. So it basically looks at those, it knows how to iterate over these nested projects, and it knows how to build images for all of these compositions. So you can do it that way. Some other clients basically come in here and go into our services and move these individual folders into their own repo, and basically have Jenkins pipelines build these individually themselves, right? And then in that case, because at the end of the day, this is going to produce either an executable jar that you can run itself, or it's going to produce a jar that you can include in a flex package composition that you could bundle together.
That's perfect. Yeah, good, perfect.
Sense? Okay. So it really depends on how you guys want to set up your environment and what makes you guys comfortable from a development standpoint. We've seen clients do both. So that's really up to you. Great question.
And also on the database level, is that correct? Or based
Yeah,
on the image
yeah,
on the left side, I see that you can use, for example, the pricing I can making on the separate database.
Yeah, so great question. So each of these services actually have a connection configuration directly to a database, to its own database and its own data store. What you can do is you can actually have all of them connect to a single data store, but each of them have to be its own schema. So that's one way to do it, right? So that's actually the configuration that you're going to see out of box with our reference architecture. Everything points to a single Postgres database, but if you start it all up and you like connect to it, you'll see each of the microservices created its own schema. So there's no kind of there's no mixing where I have a catalog service or something that connects to both of them at the same time, or like a single microservice doesn't connect to multiple microservices directly, have connectivity to a single database directly, or multiple databases directly. I apologize. So what you can do there, like later down the road, is that if, for example, you wanted to have actually physically separated databases, you have the ability to do that, right? So let's say you wanted to migrate and you started off with a single database and there are multiple schemas underneath that single database. You can later down the road, and you wanted to move pricing out of this Flex package because its own schema. It's a lot easier migration to move that segregated schema into its own database, and then make sure that you change the connection string to that other database than having it not be in the same schema. So basically there is segregation at the schema level, but also at the database level. Does that make sense?
Yeah, very clear and very smart. Yeah.
Okay. So actually, when I want to go next into this, I want to make sure I cover all this too. Let's double click into one of these services. And this is basically a diagram. If you kind of drill down even to more into every, obviously at a high level, what the anatomy of every microservice looks like. So you can see the code being structured into these different architectural layers. You're probably all very familiar kind of with these, best practice architectural patterns, right? We have the API layer, the business service layer, the repository layer, and the database layer. One particular layer you may or may not be familiar with is this idea of a mapping pipeline, which converts this idea of a projection DTO object into the actual database persistence object that's being persisted, right? So it basically, the reason I wanted to call that out is we use that internally from a broadleaf perspective to augment the projection entities that are coming in from a request from the API layer, and we actually use that from a rich framework specific perspective to add metadata on top of it to help us facilitate some of those enterprise level features that I talked about earlier, like sandboxing or tenancy and some other kind of concepts that you're going to see and I'm going to talk about in just a second as well. So I just wanted to make sure that you're aware of this idea of a mapping pipeline that translates this idea of a DTO level object that you're going to be working with from a SPA perspective, and you're passing on JSON to represent that DTO object. It's going to go into a mapping pipeline that translates that to the actual persistence entity that needs to be persisted. It's going to go into the repository layer. It's going to communicate with Spring Data JPA to actually persist that into the data store. And then at the end of the day, that persistence object is going to bubble its way back into the service. And it's actually going to create a message that could then be consumed across other services. So that persistence event is actually going to be bubbled up to the service layer, and it's going to be put onto the message broker, which is going to be used downstream by other systems, right? So a concrete example of that is, for example, if I go into the admin and the admin here represented by the single page application of our back office admin is going to communicate through the API gateway layer, and it's going to hit the, for example, the catalog service, which has CRUD operations to manage products, right? If I wanted to create a product, it's going to hit that, create product API. It's going to go through the business layer, and it's going to the mapping layer to actually change that DTO object of that product into the product persistence domain. Go through the persistence layer, hit the database. We're going to contribute additional rich metadata stuff that we internally need to support other things like multi-tenancy and sandboxing and versioning and data tracking and all that stuff that I talked about earlier. And then it's going to actually persist it. It's also going to bubble up back here, and it's actually going to create that persistence event and actually push that message into the message broker. And then that persistence event is actually going to be consumed from that message broker across other services that care about it. So for example, Solar or our search service needs to know about re-indexing a product after it's actually been pushed from our admin or a change in there. Our search service and our indexing service will take note of that change that happened in the admin from that persistence events that happen on the catalog service. So that's a really kind of concrete example of request that makes its way from one service, goes through the database layer, it persists itself into the data store specific to that service, and then bubbles up that message so that it can be consumed across other services in an asynchronous fashion. So that's a very high level overview of just the general pattern that you're going to see throughout all of the microservices. And the reason I want to kind of show you this diagram is basically, at every layer, broadleaf can be extended, overridden, and customized. So you can modify existing entities, add net new fields, add net new relationships, add net new entities into those different layers. And you can either extend or create net new business logic by implementing our own interfaces. In the business service layer, you can add net new hook points in that mapping layer if you want to contribute additional functionality to augment that entity before it's persisted. You have the ability to augment that mapping pipeline as well. And then obviously as well, you can add your net new messaging channels, create net new messaging events if you need to within that kind of messaging pipeline as well. The key part about that is you don't change Broadleaf's core code in order to customize Broadleaf. You basically get access to our jars, and then you basically add extensions on top of it. And that's a very high level. We build extension as a first-class feature to the framework. So this is a very, very, very high-level example. We're going to go in more detail here in the next session. But this is just an example of how you extend our domain, right? So there's really two things you would need to do. You would extend our projection domain and add your new field. And then you would extend the repository domain and add your new field. And really that's it. There's probably one other Spring configuration class that you would need to do to tell the system that your extensions exist. And everywhere that the system needs to use a product, it'll use your version of a product rather than ours, right? So that there's really not much other configurations other than this that you would need to do to extend the Broadleaf domain. The same holds true for service components as well, right? So the key takeaway here is that we do heavily use Spring conventions in the sense that we define implementations that heavily use annotations like @conditional on missing bean. So if you're familiar with that pattern, all that really tells you is that all in our libraries, we have implementations that have this defined so that in your code, if you ever need to extend a product service, all you have to do is define a class that extends our service, or define a class that implements our interface. And just the fact that you have that in your code base will tell our system to automatically back off. Basically, the Spring configuration manager will look at all the classes that you've defined and say, hey, oh, we see that you're trying to extend this. We're going to use your implementation instead, right? So that's basically all you need to do. You just need to extend it, and that tells our system that don't use ours, just use theirs, and everywhere in the system that it needs to use your extension, it'll use it. So again, we want to make sure that the process of extending is very straightforward, and that you have the ability to do that basically anywhere in the system.
Just a question. Is there anything that documentation or something that showing all the entities and services instead of searching in the hood to see how the architecture of the
Great question. That gives me a segue into this next section here, where at its core, Broadleaf is built for developers, and we do provide a lot of different kind of tools and resources here that we want to help enable you as an implementation team to really hit the ground running. And in particular, I want to make sure that you guys are aware of all these different types of resources that you have. And I guess really the most important kind of critical benefit here that you should be aware of is that you get full access to the source, right? As an enterprise level customer, you get, you should have seen the mechanisms in that. If you haven't seen that video in the prerequisite videos, there was a guy that kind of showed you how to download the sources in your IDE when you want to kind of look at the different features on there. And we highly recommend you have that set up in your IDE. But that's one of the main ways to kind of, as you debug through the framework, or if you want to debug through certain flows, through your IDE is a really good resource to do that. And making sure you're not like working in that black box, right? So secondly, as a developer, there's these key resources that you should be aware of. One is what I just showed you earlier, is this developer portal. I want you to really make sure that you're aware of just the sections here. The first one in particular is, let's go back here, the services level documentation. So if I click on this services catalog section here, this basically has all of the kind of backend Commerce Core microservices in a list that you can kind of click into, and it can kind of tell you out of service layer the functionality that particular microservices is responsible for handling, and it has sort of the let's go into that particular domain. And a lot of these are more, because a lot of these have more rich functionality than others, because obviously admin navigation is very small, and it doesn't really do as much as, for example, our auth service. So some of these have really more in-depth documentation that talk about the details of that particular service. It talks about the data model that might be involved for that particular microservice as well. The other resource, so the first one, making sure that you're aware of, is this services catalog. So if there's a particular feature or recommendation or kind of concept or category of thing you're looking for, first thing you should probably look at is the services catalog. The second is also looking at the open API. So if we go to actually admin.vocdemo.com API/docs, you're going to get access to, and you have the code to deploy this to your own local environment as well. But you can actually go to this URL if you just want to see and play around with it without having to deploy anything. Go to this demo, and this is basically an open API, interface that you can use and look at all the exposed RESTful out-of-box endpoints that are available to you, that you can use from a consumer-facing. If you're this is really helpful for front-end developers, right? So if I want a front-end developer and I want to look at what are the APIs that are available out of box, you can come in here and kind of look at the different APIs that are exposed at each individual microservice layer, right? So you would pick the microservice that you're looking to work with, look at the endpoints that are exposed for that microservice, and you can actually play around with this and authorize yourself. There's some C data that we also give you that allows you to authenticate here and actually use this as a way to play around with this as well. So making sure that you're aware of that open API as well. So I'm going to touch on these as well, but there's some other high-level sections that you should be aware of. Just the architecture section on developer portal here talks about a lot of the things that I just went over today. If you want to review some of this, there's some really good in-depth discussion around the reference architecture and the tutorials and getting started locally, kind of pointing to here, as well as kind of DevOps questions and going to production. So make sure that you guys are also aware of considerations of what you want to do from going to production, making sure you're aware of being able to change the default, public keys and private keys that are provisioned out of box when you're ready to go to production as well. So just make sure you're aware of that section, as you move throughout the implementation. So again, developer.broadleaf.commerce.com is one of the best resources to start off with. And then other helpful resources that you should be aware of is going back and provisioning your own private demo. So if you don't actually want to get your own demo running locally and you just want to kind of play around with it, you do have the option to come in here to our dev portal. And if you go to home and click, try it out, you can sign up for one. And what this does is kind of provision your own application, and you'll get a link to something like, it'll look like this demo and some random number, and you'll get your own version of this where you can play around, and you get your own login to the admin where you can play around with it, and you can log in and modify things on your own kind of sandbox environment. So that's another way to experiment with the open API. And then finally, making sure you're aware of this knowledge base as well. So there's ms-support.broadleaf.commerce.com. If there's something that you might have run into from an environment perspective, likely that has happened in the past with some other clients, and there's kind of a knowledge base article that you might want to search for here as well. So just making sure that you're aware of all these different resources that are available to you as you kind of play around with your implementation and start off there. So hopefully that makes sense. There's a lot of kind of documentation there around what's available and how you might want to navigate through those resources as you progress through your implementation.
You mentioned there are videos to set up the environment locally using the IDE. Where is it?
Yeah, so you're talking about the how do we set up the local environment? Is that what you're asking about?
Yeah, but I think you mentioned there is a video. Is it correct?
Oh yes, yeah. So I'll send that afterwards. There was a list of like 5 videos that walk through getting your local environment set up, and one of the videos kind of went through. It was one of the last videos, how to set up your debugger and what you need to do to get to download the sources. It kind of shows you that in the video.
Where is it? Where can I find this video?
There's a link that I have, and we can send you that after this call.
Perfect. Okay. Another question: is there any how can I say the tool that's showing the bugs, if there is the enhancement, the versioning of the product?
Yeah, great question. So like every you'll probably want to go to this section as new releases come out. We're going to basically have what we call release trains that come up and talk about the new features that are being added. And if you need to upgrade or move to that particular section, we're going to talk about what you might need to do to move to that particular version. So that and this is going to have links to more in-depth details at each service layer. So as you kind of need to consume additional versions, we're going to have communications back to you guys that point to this type of release note, which we'll talk about. Here's what you would necessarily need to do and be aware of to move to the next version. Does it make sense?
Yeah.
Okay.
But still, also, is there any tracking for the is the how can I say, in this page you mentioned the release note, but is there any also tools that discussing the history of bugs, what the issues of the bugs and so on?
Yeah. So I think
Or
that if I go back, those release notes should have the bug fixes or a description of the bug fixes that go into that particular release. So and you can also email us at our support if there's a particular one that you're trying to fix. There's not a, if you're looking for like a public Jira board or something, we don't have that. But typically what we would do there is if there's bugs that you're trying to keep track of and that you've identified, we have a dedicated channel for that from a support perspective that you would email and we would communicate you as part of that channel. So there's not like a Jira perspective that you go to.
yeah, I got it. In the Git, how should I know the release that already exists on the Git?
I'm sorry, can you say that one more time?
On the GitHub, on the repo,
Yeah.
how can see what the version that currently that
Yeah, so how do we see what version you're on? Yeah, great question. So if you go in here and each of these different projects define a POM. So in microservices demo, you're going to see this POM XML is going to come in here. And the number one thing you're going to look for is this idea of a release train. So this release train is going to basically, what this is basically a harmonized BOM that we keep in harmonization with all the dependent services. And really what you would necessarily need to do is upgrade these to the next version. And really that's all you would need to do to upgrade to the next version is change the version here. And we would tell you this is what you would necessarily need to do. What we've also been doing is actually creating pull requests on these starter projects. Actually, I don't know if I have them here, but we would basically come into these starter projects and show you the changes that you would necessarily want to do to these starter projects to upgrade to the next version, and then show you, like, here's the diff that you would necessarily want to do and apply to your own code base as well. So that really helps implementers kind of look, and here's the changes that apply to me. I'm going to move that to my own code base when we move to the next version, right? So we'll tell you, but in general, it's really just an update to the release train. And then if there are any code that needs to happen or a configuration change that needs to happen in these starter projects, you would also get that through a git diff here as well. Good questions.
Okay.
All right, so I know we only have 20 minutes left, and I really want to kind of set up the last part of this as going and setting you guys up for the next couple sessions throughout the rest of the week. I covered this a little bit, but I'm going to go over this again. You know, in our core commerce microservices, there are over 30 different microservices, and it is helpful to think about them into these architectural kind of categorizations. Some of them being the admin level of services. So such as ones that power that back office admin are things like our metadata service, the admin user service, the admin navigation service. So we have those that power the admin, the back office admin. we have those compositional services or those orchestration level services that I talked about earlier. And then we have those core resource care services, which are really specific to a bounded context, right? And have a specific domain that it's responsible for. And then finally, we have the list of foundational services here that really, in our mind, underpin the entire ecosystem and provide those enterprise level features like tenancy and multi-catalog capabilities and sandboxing and things like that. So just keep these categorizations in mind as we walk through the next part of our section here. And we're going to focus on that top categorization here about the admin for just a few minutes here, and talk about the architecture of the admin and those admin level services. And the way that the admin works is it is basically composed of several different components, right? So we have a React application which services that helps render those admin screens that I think you saw here. It was, if I go in here and I'll kind of give a brief demo of this in just a second. But this is a React client application, and it knows how to communicate with all the backing microservices on the back end. And then there's a level of microservices that help power the dynamic nature of what you saw here. For example, our metadata service, our authorization service, our navigation service, all of those microservices that we can categorize as our admin level services help make that admin dynamic and provide security for building out those screens for the back office admin. And then the third set of components here are the core commerce services, which help drive the data that's powering the screens for the admin, right? And then finally, the fourth set of components here are services that you might have and you might want to administer in the same back office admin that are outside of the broadleaf services. So one of the unique things you can do with our metadata framework and our admin component libraries is build screens for services that don't even exist in the broadleaf ecosystem. So if you wanted to also administer and build admin capabilities within the same broadleaf office back office console and leverage the same authentication mechanisms that are built in and kind of front your services with what we call metadata, you can do that and build that on top of your services as well. So at the end of the day, our admin is what we call metadata driven, and it's this metadata that drives the content and structure of what you see on the front end. And it's that React application that interprets that metadata to make it be dynamic, right? And to help build that, we provide a Java DSL to help back end developers. If you're not familiar with React, or if you don't really care about learning React, you don't necessarily have to know React to build out the net new screens in the admin. You can utilize our Java DSL to help build out the metadata on the backend layer. And again, just like our core commerce services, our admin is also built for extension because of this metadata-driven architecture that's built in here. We have over 100 out-of-box components that drive, how different ways to manage different entities. So whether that's a view here that has WYSIWYG capabilities, or it has like lookup capabilities to address, complex relationships within entities. At the end of the day, you're producing this JSON structure that's being fed to the React application, and that JSON structure kind of tells you the different components it needs to render to manage that data. So this is kind of a really brief view of the JSON that's coming back. And again, you don't necessarily need to know React to build out this JSON. If you know Java, You can use our Java libraries to build that using our Java DSL on the back end using our metadata service. And you can build out these kind of back office screens pretty easily with those component libraries. So if you wanted to go in and heavily customize this, you can also do that as well. If you wanted to go out and actually customize and build net new React components and build them into the library, if you want a really custom back office experience, you can also do that as well. But it really depends on the level of customizations you want to do at that back office layer. So that's really at high level, just being aware of the capabilities here. There is a specific session that you're going to have on like day 3 or 4 that goes into more detail around the storefront and admin and kind of working as a front-end developer on how to customize this on a later session. So just want to make sure that you guys are aware of this going in. We talked about this earlier. Just to reiterate, there is a level of services that we call the composite or experience layer services that aggregate information across other services. One of the general notes that you should be aware of for these, I'm not sure if, I was able to talk about that, but it's this idea of these services actually don't have a persistence layer. They don't talk to a database directly. All they do is aggregate information from backing services. So they'll all connect through external providers to backing services, which in itself may have database connectivity or persistence, but these themselves don't persist anything. They'll just aggregate data to backing services. And generally, from a security firewall perspective, it's useful to think about these composite services as typically the main APIs you would expose to a customer-facing or client application, unless you really want direct access to a resource tier service, unless it's a back office application. So our back office admin actually communicates directly to these back office services through the API gateway, but our storefronts primarily deal with these orchestration services. And then finally, our back office services or our core commerce services make up the majority of the services that you're going to see from a bounded context perspective. Again, I would go into that services in our developer portal, go to that services catalog. You can go in here and click into the details of each particular resource tier service. And that will give you more details around the details of what each particular microservice is going to offer you. And then finally, we do have some pretty important foundational services, again, that underpin the entire broadleaf ecosystem, auth being one of them, sandboxing and tenancy, again, that once you have those deployed, and in general, we have clients that pick and choose which services they want to deploy to their infrastructure. So they might not be deploying the full broadleaf ecosystem. They might have different services in play. If you're going to go down that route, you're still going to want to, in most cases, deploy these as part of the foundational services, especially if you want to also deploy the admin as well, but only manage, let's say, a few of the core commerce services within broadleaf. So there's also that capability, but we want to make sure that you're aware of these foundational services that provide kind of these holistic capabilities across all the services. Okay, so I know for the last 10 minutes, I'm going to kind of breeze past this, but this is kind of very important that will set up some terminology that is going to be very useful in these next sessions. And you're going to hear this throughout tomorrow's session as well as the rest of the sessions, but there are a lot of components and concepts in the framework, and those pieces can be used in a variety of different ways to solve a lot of different problems. And so those solutions to those problems can be built using these 4 key concepts. And the first concept that you should be aware of is this idea of tenancy, right? So a tenant in our system is a distinct independent operator of the broadleaf services. and tenants can share the same infrastructure, like a single installation of the broadleaf microservices, but have segregated data from other tenants on the same installation, with the key being that tenants cannot see data in another tenant, right? In most cases, and unlikely in your case as well, you're going to have a single tenant, and in a lot of cases, you might have a single tenant with multiple applications. So underneath a tenant, you're going to have this concept of an application, and an application typically represents something like either an end customer storefront or a commerce-facing front end, but really it can be used to represent any type of segmented property of a tenant. And the way you do that is to use applications to manage things like catalogs and profiles. So catalogs represent a grouping of categories, products, and SKUs. And catalogs, products, and SKUs can be created at a global tenant level and shared across applications, or they can be created at each individual application level if you don't need to share those catalogs between those applications. And then finally, we have the concept of a profile, which are very similar to catalogs. They also have this idea of inheritance and hierarchy as well. But instead of focusing on product data, you all can also use that to maintain content-specific data as well, like theme fields and content models and items as well. So just using those core concepts, a single installation of broadleaf microservices can support a wide range of different applications and business models. So for example, if you're a large B2C retail scenario, you might need to support different brands or different storefronts or multiple geographic regions using this idea of applications. So I can have a single installation of broadleaf, a single unified admin that allows me to manage these different applications, all from a kind of a global tenant perspective. If, for example, in a B2B implementation, you might want to use this idea of different catalogs for different, customers in a B2B perspective. So you can manage, catalogs here at a global level and propagate those to different applications and have those be segmented by customer in a B2B scenario. We've had clients in a franchise or a dealer model kind of organize catalogs in a centralized model where things are maintained at a global corporate level and then propagated to all their franchise applications that inherit from this global level. And then we've had clients that use us in a marketplace model where I have different vendors log into the admin and manage their own vendor data and then push their data into a centralized marketplace application where a single application kind of inherits and utilizes those catalogs in that way. So again, just to recap, these concepts of tenancy, applications, catalogs, and profiles can be used in a variety of different business models, and they're used to support a lot of different scenarios that really need to benefit from this idea of inheritance or multi-tenancy or organization. So any questions about that? I'm going to give you a brief demo with the last few minutes that we have here of the admin, and that's gonna kind of tie in everything that I showed you here of those concepts that I talked about, right? So I just logged in as a master global admin user, and when I logged in, because I'm logged in as a global admin user, you can see here this idea of what we call an application selector here at the top, right? Because I'm a global admin user, I have the ability to manage all the applications that that are provisioned in this installation of broadleaf microservices. So at least with the demo data, and you're going to see this with the C data that we gave you, we have 3 different applications that can be managed, and these can be thought about as different storefronts that have their own catalogs, that have their own customers, that have their own orders, and you can all manage them from a single, from this global perspective. And you can, again, if I don't choose an application, that's when we talk about being in a global context and I'm managing things at a global level. So if I go back to this diagram, I might want to manage products and catalogs at this level, and then propagate those changes to applications that inherit from things that I manage at this global level. So you can set up really easily catalogs and products and SKUs at this, like a master catalog at this level, and change items, change description of items at this level. And then let's say I had 1 or 2 applications that inherit from this master catalog. The moment I click save and promote, I can configure it to automatically propagate those changes to those applications that inherit from this master catalog at this global level, right? So there's this idea of maintaining things at this global level and really easily propagating those changes to those applications that inherit from it easily. And we have the way that we have this data set up in our C data is to demonstrate that as well. So I can actually make a change to a master catalog at the global level and have that change automatically be propagated to the child application that inherits from it here with Heat Clinic. And I'm just briefly, I'm going to go through the different sections here. I'm in an application context here where you're going to see in how this admin navigation is structured is really segmented by the different microservices that support those sections as well, right? So catalog primarily has sections that allow you to, administer things that are very relevant to a merchandiser. So for example, I want to manage the category taxonomy or products that are associated with a catalog. And within this, there are a lot of key components that you're going to want to look at and be familiar with. For example, the idea of maintaining different product types. So whether it's a standard-based product or a variant-based product that's like a t-shirt and you have variations, or if it's a bundle or it's a selector product, there's a lot of kind of advanced product types that you can configure from a merchandising perspective using the catalog microservice. And that's kind of encompassed by this section here in our admin. In addition to that, you're going to run into our pricing microservice that has the ability to manage like price lists. And then this actually encompasses 3 different microservices. Campaign is a different microservice, and Offer, ones that manage robust kind of promotions and discounting mechanisms. You'll manage kind of at this section level. This is a content management. You might actually not see this in your version. This is actually in our 1.8 version that's going to be released in the next few weeks. But here you'll see this idea of managing content model and theming capabilities at this content level. And then finally, our commerce section here will help you administer, our transactional level of information. So whether that's a customer service agent type functions where I'm looking for customers, managing customer segments, managing orders for a particular application, you'll see all the kind of transactional level of services in this one. Search, search you can manage at the application level, but also at the global level. So if I wanted to manage search fields, things that are going to be able to be indexed from Solar, you can manage here at within this kind of interface. Processes talk about long-running back office jobs. For example, if I have scheduled jobs that need to do things like an import or an export, you can come into this section to administer those types of features and flows. And then finally, application updates. One of the things that I'll just show you really quick. If I go into a catalog and I make a change to a product, this is this idea. I keep talking about this idea of sandboxing, and this is what I mean by that is for particular entities, and you'll see this, a lot of entities have this idea of sandboxing, this data tracking concept where every version or change you make is tracked. and every single field at a very granular level is tracked. And you can see here, I, as an admin user, can make a change, and it is local to my user, and I have this in my sandbox environment. I can actually promote this, and when I promote this, I have the ability to deploy this immediately, or I can wait, and if I have multiple people configured in the system where I need to have someone approve this before it actually goes into production, that's where our sandboxing and approval flows come into play. And if I go into this application update section, I can come in here and actually see that, pretend that I'm a different user that doesn't have this privilege, and I need to have an approver kind of look over these changes before it actually gets into production. I can view at a field by field level, like what has changed on that entity, and approve those to actually be either deployed immediately into production or actually be scheduled to be deployed at a later date, right? So that's what I mean by a sandboxing and approval workflow, is that all of or a lot of our entities have the ability to define this data tracking component where it can go through this approval workflow where you can set up and make sure that you're auditing, and someone can come in and see what is being changed and approve that to go into production at a certain date and time. So I know we are 4 minutes over. I apologize for that. I hope you guys had a good overview of really the high-level components and services in the system. And I'm going to pause here for questions and make sure that I can answer questions before we kind of wrap up for the day. And I'm happy to take a lot of these questions offline and kind of talk about this and make sure that we cover these in the next session as well. So let's start there. Is there any other questions that we should get through now, or is there something that you want to kind of make sure we cover in a session the rest of this week?
Yeah, just a question, but maybe we can cover later. You discuss about the documents that describe the technical part. Is there documents that describe the business, or maybe the admin tools, the features that already exist there, and how can play in the admin tools and so on?
Yeah, so in terms of business user documentation, we do have some tutorials. These actually link out to some blogs, for example, and this is, I think, might be really relevant to some of your merchandisers that want to think about creating advanced products. So whether that's a standard-based product or a variant-based product or a bundle, there's a few kind of tutorials that you're going to want to go through. There's not a really robust set of business level documentation, but if there's specific use cases that you want us to make sure to cover, let us know. But in general, we want to make sure that you're aware of the business users guides that we do have that link out to various merchandising specific guides that we have, at least from a documentation standpoint here. Okay, good question. And anything else?
Yeah, I have a question here. I want to know how you handle logs. Are you using ELK stack or another thing?
Yeah. So in terms of, I guess you're talking about sort of, did you say logs?
Logs.
Yeah. So logs are, in terms of, up to you in terms of the actual centralized logging application. What we do provide from a reference architecture is the ability to deploy your own Prometheus, Grafana, and ELK stack, or actually EFK stack. However, you're going to want to, I was talking to Mahmoud about this, if you're going to use OpenShift, and I'm not sure if the OpenShift has its own centralized logging framework and things that it might want to do. So in that case, we have a reference of how to maybe hook in a particular configuration or a Jaeger agent that knows how to spit out the logs into the format that you need in order for it to get ingested into your particular format. Because at the end of the day, you can ingest it however you want to. We don't dictate that. We do give you a reference of how you might want to use EFK if you're going to deploy EFK yourself, and an example configuration of how to ingest the logs that you're coming out of those Docker images from all the pods.
This recommendation is gonna be represented in these sessions, right?
Yeah. So are you talking about the which one in particular are you talking about?
You said you don't dictate the using of ELK or EFK stack,
Yep.
but you do have a recommendation, and you will give it to us.
Yeah. So yeah, well, let's take that offline because there are definitely things in our Helm charts that we support, like the ELK stack, and it talks about what we do here, and that's probably a conversation with Mahmoud and our team.
Okay, we will not use the ALK stack. We will integrate with Kibana as it is Vodafone centralized log management.
Yeah, and we internally use Kibana and EFK to ingest those logs. So if you guys want to do that the same, I think there's going to be it's similar setup. So, but I think you might want to do that in terms of how you want to deploy that in your OpenShift environment, right? So that's really however you ingest those logs for all your other applications on OpenShift. Right?
Okay.
Yeah. Good questions. All right. So again, feel free to send me questions offline if there was something that you guys were holding on to. And we will continue this tomorrow. And then tomorrow, particularly focusing on the resource tier catalog and catalog browse microservices, and focusing on extensions and deep diving on really coding and debugging those particular flows. So again, let me know if you have any questions, and thank you for joining today, and hopefully this was helpful.
Yes,
Yeah.
thank you.
Thank you. Thank
All
you,
right.
Albert.
Thank you, guys. All right. Bye.
Bye-bye.